Hello my dear friends, welcome to the video. Today in this video we are going to start our new chapter, our second unit, equilibrium of forces. And today in this video I am going to give you a brief introduction about on our second unit, right? And we all know this word called force, right? It is an external agent which is applied on a body in order to create a motion. This is the simple definition of force. And we don't know what is this word equilibrium. So, for understanding this word, let us move to another page and understand its definition first of all. See, equilibrium is nothing but it is the condition at which no forces are acting on the body. At which no forces are acting on the body. So, for a better understanding, let us move to some pictorial representation, or let us understand it from pictures. Let us consider a traffic lamp. Let us consider a traffic lamp which is uh, hanged with the help of string to the rigid surface, rigid top. So what happens here? This is the string, this is the string, and this is the lamp, and this is the rigid roof, maybe. Right? So this lamp will definitely have some weight, and that weight will act vertically downward direction like this. So with the weight which is being applied towards down, the lamp has to fall down. But this is not happening. Why is this not happening? Since it is attached to a string, the string is holding the lamp in the opposite direction. Opposite direction in the sense, as the weight is acted, let us say it is acting with a weight of W newtons. W newtons. W newtons. The lamp is having a weight of W newtons, and the string to which the lamp is attached is also applying a reverse and equal magnitude of force in the opposite direction. So let us say, see, the weight is completely acting in vertical direction. With the action of this weight, the lamp has to fall down, but it is not happening in the case. Why? Because the string with which it is attached to is also applying some force on the lamp, which is pulling the lamp in the upward direction. So that is the reason the lamp is standing firmly, the lamp is hanging firmly and not coming down, and also not moving up. So what is this string doing? String is trying to pull the lamp in the upward direction. So in this direction. With what force it is moving? With what force the string is pulling the lamp? With the same force, W newtons. And then only there will be no external force applied on the lamp, and it will hang firmly without moving towards down or towards up. So let us try to clear. Here two forces are acting on the body, and I am telling no force is acting on the body, but let us make it clear. So let us calculate vertical forces and horizontal forces. Can you see any horizontal force in the picture? There is no horizontal force, it is 0. And let us go for vertical forces. Is there any vertical force acting towards down? Yes, that is W newtons. Let us not mention the units. W is the force which is acting vertically downwards. So you all know the sign conventions. If the force is moving towards down, they can be taken, if the forces moving down are taken as negative, the forces which are moving in the upward direction should be taken as positive. Or if the forces which are moving towards down are taken as positive, the forces which are moving up must be taken as negative. Here I have taken the forces which are coming down as negative and the forces which are moving up as positive. Plus I'm adding up all the vertical forces, right? And in vertical forces, when I observe for the vertical forces, a vertical force of W newtons, which is the weight of the lamp, is acting vertically downwards, and the force with which the string is trying to pull the lamp in the upward direction is as same as the downward direction's force. So this is another W. And what is the summation of minus W and plus W? It will be 0. And here you can see the horizontal forces 0, vertical forces also 0. This is the condition at which we can conclude it by saying there is no force is acting on the body, since both the horizontal and vertical forces are 0. So there is no force being acted on the body. And let us make another point very clear. You might be wondering, how can weight is equals to force? How come weight is equals to force? Generally, we all think that weight is the quantity which is measured in kg and force is the quantity which is measured in newtons. How can these both quantities becomes equal when in the case of pulling and the weight which is acting downwards and the string which is applying some force in the upward direction? How can these both can be equal? So let us take another page. Let us make it a bit clear. So according to Newton's second law, what is the definition of force? It is the multiplication. It is the product of mass into acceleration. What is the unit of mass? Mass is measured in kilograms in SI units, and acceleration, the units of acceleration is meter per second square. And what is the formula for weight? That is W equals to mass multiplied with acceleration due to gravity. Mass is always measured in kilograms and acceleration due to gravity. So the general unit of acceleration is meter per second square, irrespective of what kind of acceleration it is. Here G is acceleration due to gravity. So whatever the acceleration it is, the unit of acceleration is meter per second square. And force is measured in newtons. So here Newton becomes equals to kg meter per second square. Here for weight we have got the units kg meter per second square. So kg meter per second square can be newtons. So that weight also can be a force. Right? Hope you have understood. In our next video, we are going to be discussing about how to draw free body diagrams. How to draw free body diagrams. And stay tuned to the channel and try to, with with high difficulty, please try to tap the subscribe button so that you will get some notifications and you will be stay tuned to these topics continuously. Thank you so much.